If you tried to convince Congress today that the Earth was hollow, and you knew how to get inside it, you'd be laughed out of the building. In 1818, a former U.S. Army officer did exactly that, and it worked well enough that his theory helped set in motion a real, congressionally funded scientific expedition to Antarctica. Not a fringe pamphlet nobody read, an actual circular mailed to colleges, scientists, and government officials laying out a theory of concentric hollow spheres inside the planet, with openings at the poles wide enough to sail a ship through. How a theory this strange got taken seriously enough to shape real U.S. exploration policy is a story about how persistence can outperform evidence, at least for a while. On April 10, 1818, a former Army captain named John Cleves Symmes, Jr., sent out a printed circular number 1, to colleges, scientific institutions, and government officials across the country and Europe. It declared, in his own words, that the Earth is hollow and habitable within, containing a number of solid concentric spheres, one within the other, and that it is open at the poles 12 or 16 degrees. He offered to personally lead an expedition to prove it, and asked only for 100 brave companions and government backing. This wasn't a private diary entry or a tavern rant. It was a formal, mass-distributed proposal, treated seriously enough that Symmes spent years afterward touring the country giving public lectures on it. Symmes wasn't just asserting this. He had an argument, built from real observations stretched to fit his conclusion. Migratory Arctic animals that seemed to travel north rather than south for winter. Magnetic variations recorded near the poles, and the aurora borealis, which he took as light escaping from the planet's interior. His central mechanism leaned on centrifugal force. He argued Earth's rotation would flatten the poles enough to create a genuine passage inward. The obvious problem was gravity. If the inside of a hollow shell pulled you in every direction at once, you'd be weightless at the center, not standing on an inner surface. Symmes' answer was to simply reject Newton. He argued gravity wasn't an attractive force tied to mass at all, but a kind of push, a claim built specifically to keep his interior world standing upright. One of the people who heard him lecture on all of this didn't just believe it, he built a career on it. A newspaper editor named Jeremiah Reynolds became one of Symmes' most devoted converts, quitting his job to join Symmes on the hollowearth lecture circuit, traveling town to town, promoting the idea of a habitable interior world with its own sun, its own ocean, possibly its own civilization, reachable through the polar openings. After several years of touring together, Reynolds began to lose faith in the more fantastical claims, the inner sun, the hidden civilization, but he didn't abandon the underlying ambition. He redirected it, campaigning instead for a real scientifically legitimate government expedition to the polar regions. The theory that first got him on the road wasn't the theory he ended up defending, but the drive it gave him never went away. That redirected ambition eventually reached Congress. Reynolds spent years lobbying lawmakers for funding, and his advocacy played a real documented role in securing support for what became the United States Exploring Expedition, which launched in 1838 under Lieutenant Charles Wilkes. 6 ships and hundreds of men surveyed the Pacific and, crucially, Antarctica over 4 years, producing the first confirmation that Antarctica was a genuine, solid continent rather than a scattering of islands or open polar sea. The exact opposite finding of what Symmes' original theory needed to be true. A theory built on an opening at the pole helped fund the very expedition that proved there wasn't one. So why did any of this get this far in the first place? Nobody had actually reached the poles yet, in any real sense. This was decades before anyone came close, so a theory about what might be there didn't have to survive contact with hard evidence because there wasn't any yet. That gap is exactly where Symmes' theory lived. It wasn't unusually persuasive science, it was an unusually confident guess filling a genuine, wide-open blank on the map, at a moment when American ambition for exploration and discovery was running high. Once Wilkes' expedition actually reached the ice and charted a real solid landmass, the specific gap Symmes had been filling closed for good. But the idea itself didn't die with the evidence. Hollow-earth theories kept circulating in fringe pseudoscience for the next 2 centuries, completely unbothered by the fact that the exact expedition their originator helped inspire had already disproven them. So the next time a hollow-earth theory shows up in your feed, remember, it isn't new. It's a 200-year-old idea still circulating, long after the expedition it helped fund found nothing but solid, frozen continent where the opening was supposed to be. What's the actual lesson here? That bad theories can still do real, useful things on the way to being wrong. Or that any plausible-sounding gap in human knowledge will always attract someone confident enough to fill it, evidence or not. Either way, the Antarctic ice that ended the theory is still there. The theory, somehow, isn't.